So in the previous video, we have seen some introduction part of endothermic and exothermic reactions, whereby we have said endothermic reaction is a chemical reaction that absorbs heat energy from the surroundings, and exothermic reactions, we said, is a chemical reaction that releases heat energy to the surrounding. So in endothermic reaction, heat energy is absorbed from the surrounding, so the temperature of the surrounding decreases and the temperature of the system increases. And for exothermic reaction, the temperature of the surrounding increases while the temperature of the system increases. So in this discussion, we will look at a question that is involving endothermic and endothermic reaction, that is energy level diagram. So we're told draw a labeled reaction pathway diagrams for endothermic and exothermic reactions using the information provided. So this is what we're given here: reactants, products, enthalpy change for the reaction, activation energy. So we are supposed to draw an energy level diagram for exothermic and endothermic reaction showing reactants, product, enthalpy change for the reaction, and activation energy. So let us begin with endothermic reactions. Endothermic reactions. So let's draw our energy level diagram. So on this part, on this side, we have got progress of reaction, and on this side we have energy in kilojoules. So for endothermic reactions, reactants and products are drawn horizontally, showing the reactant on the lower part of the energy level diagram and the product on the upper part of the energy level diagram. So that will be the reactants. So this is the reactants, and this is the products. So the activation energy will be the energy when the reaction starts it up to the energy at the top of, or the peak of the curve where the reaction falls. So activation energy generally is the minimum amount of energy that the colliding particles needed to react. For chemical reaction to occur, particles must collide each other. So when colliding, they use energy, they require energy. So that energy is the activation energy, and it is shown when the reaction begins up to where the curve, the peak of the curve, that is. So we will draw like that. So that is the activation energy of endothermic reaction. Activation energy denoted by E small a. So under the enthalpy change for the reaction is the energy from the product to the, from the reactants to the product. So that is the energy enthalpy change for the reaction. So this is the enthalpy change, or the overall enthalpy change. So which it is denoted with change in H, and the enthalpy change for endothermic reaction is positive. So you show plus there because the energy is absorbed from the surrounding. So what about exothermic reactions? Let us draw the energy level. Exothermic reactions. So on this side, we have got progress of reaction. And on this side, we have energy in kilojoules. Energy in kilojoules. So exothermic reaction, the reactant and the product are also drawn horizontally, but this time around, the reactant is drawn on the top part of the energy level, and the product is drawn on the lower, is shown on the lower part of the energy level. So here we will have, that will be the reactant, and this is the product. So here we have reactant and products. So the activation energy is shown when the reaction starts up to the peak of the curve. So this is the activation energy. Activation energy that is E small a. And the overall enthalpy change will be the energy from the reactant to the product. Energy from the reactant to the product. So energy from the reactants to the products. And we show by arrow like that. So this is the overall enthalpy change. Enthalpy change. And it is denoted change in H, and the enthalpy change is negative. The enthalpy change for exothermic reaction is negative. So that is the difference between endothermic and energy level showing endothermic and exothermic reactions.